Hi guys, today we're going to be talking about day 3 notes based on this topic of discriminant. Today is 3/9/16. I'm sorry I'm not there to do the puzzle with you. I can't put one up for 3 days in a row, but we will talk about some puzzles, I promise, when I get back. So today we're going to be describing the nature of the roots of a quadratic equation by calculating the discriminant, which is b squared minus 4ac. Now that should be familiar to you because it comes from your quadratic formula. X equals negative b plus or minus, here we go, square root b squared minus 4ac all over 2a. Alright, so again, we're calculating the discriminant, b squared minus 4ac, to help us determine if roots are real or non-real. And we're just going to kind of look our way through this flow chart here. Roots can be described as real or non-real, or in other words, imaginary. If they are real, then they cross the x-axis. If they are non-real, then they don't cross the x-axis. If they are non-real, then that's where we stop. We don't describe them any further because they are, in fact, imaginary. However, if they're real, we can keep going. They might be unequal, meaning you have two roots, or they might be equal, meaning you have one root. Equal roots are always rational, and we'll talk about what rational means in just a minute. Unequal roots, meaning two different roots, could either be rational or irrational. So if we take a look at examples of real versus imaginary numbers, you can see that real numbers are any number in the world, including pi or, the log of some number, even though you don't know about logs yet. We'll talk about them in a couple units from now. But it's any number in the world, positive, negative, a decimal that goes on forever, a decimal that's a nice decimal, etc. Imaginary numbers, like we talked about a couple classes ago, have a square root of a negative number. That's where the imaginary part comes in. Because remember, square root of -1 is I, the imaginary number. So then when we talk about rational versus irrational, rational is any number that can be written as a fraction. I'm sorry, my handwriting is so messy on my iPad. Probably not much messier than the smartboard, but I feel like it's 10 times worse. But, again, rational numbers are any numbers that can be written as a fraction. Like this decimal right here can be turned into a fraction. It's actually 1/8. Any number that can be written as a fraction. Irrational numbers are numbers that go on and on and on and on forever. Like if you type in the square root of -2 in your calculator, it's going to stop after like say 4 or 5 decimal places, but it actually keeps going and going and going and going and going forever and ever and ever. Just like pi. There's an infinite number of decimal places that come after 3.14. Right? It keeps going, 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 going. Irrational can never be written as a fraction. If you're not sure whether a number is rational or not, just use your calculator, and here's some steps for how to do so. If it changes into a fraction, then it's rational. If not, then it's not rational. Go ahead and flip your paper, and then we'll talk about some of those discriminants and how to describe the roots based off of what it is. So as I mentioned before, the discriminant is the name given to the expression that appears under the square root sign, or that radical in the quadratic formula. And it helps us to determine the nature of the roots. So we're going to look at 4 different cases here where we find the discriminant, we actually calculate the value, then we look at where the roots are, and then we talk about how many there are and the nature of them, being whether they're real or imaginary, rational or irrational, equal or unequal. So again, calculating the discriminant is at b squared minus 4ac. So in order to do this, the equation must be equal to 0. Then we just identify a, b, and c. So I'm going to put my 1 in front of the x squared. That will be my a. Then I can read right down the line because they are in order. B and c. So calculating the discriminant will be b squared, 2 squared, minus 4 times something times something. Take 30 seconds to fill in those blanks. Just kidding, not 30 seconds. That's way too long. A is 1 and C is -3. So now we're going to actually plug this into our calculator. This time I'll give you 30 seconds. And we end up with 16. So now we notice that 16 is a number that's greater than 0, and if I were to ask you what the perfect square or what the square root of 16 is, you could tell me that it's 4, meaning a nice number. So not only is it greater than 0, but it's perfect. So our discriminant is 16, greater than 0, and perfect. Now if we look at the roots here, we can see that there are clearly 2 of them. Roots again are where you cross your x-axis. We have roots at -3 and +1. Now if we talk about the number of roots, there are 2 roots. And now we're going to describe the nature. Now obviously we know what the roots are. We just said that they are -3 and +1. These are real, because again, it's where it crosses the x-axis. They are also rational. And this is because I could change -3 into a fraction by simply putting it over 1. I could change 1 into a fraction by putting it over 1. Now, the next part is whether they are equal or unequal. -3 is not equal to +1. The roots are not equal, or in other words, unequal to one another. So we just described the nature of the roots, and although we based it on the graph roots, we know that this always corresponds with a discriminant that is greater than 0 and perfect. So that's case 1. If you have a positive perfect square as your discriminant, b squared minus 4ac, then the roots are always real, rational, and unequal. Alright, we're going to take a look at case 2. You're going to start by calculating b squared minus 4ac, that discriminant. Remember, get it equal to 0, label your a, your b, and your c, and then start plugging in. Now I'm going to have you stare up here at the board for a second, and I know that you guys are probably plugging in, but based on the fact that I have 1 and -3 for my A and C, would I get full credit, or would I get the correct answer even, based on the way that I've written this? -4 squared minus 4 times 1 times -3. Hopefully you are screaming no. And the reason is, remember, we forgot parentheses here. -4 has to be in parentheses before we square it. Go ahead and type that into your calculator. And you'll find that the discriminant is 28. 16 plus 12 more. Now 28 is still greater than 0, just like the last one. But if I asked you for the square root of 28, I don't think you could tell me what the number is. Sure, you could give me a decimal, but it's not a nice number, meaning that it's non-perfect. So if we look for the roots here, I've got 1 here and 1 here, and they look like they're between nice squares, right? So here we're going -1 point something, and what is that, 4 point something? Maybe that's not even, yeah, 4 point something. So these are not nice numbers. Now they're still real. There's still 2 of them. Let's start there, 2 roots. They are still real because they are crossing the x-axis here. It's just that they're not rational. They cannot be written as a fraction. We don't even know what these decimals are. They're hard to find, and so we're going to call them irrational. And then, of course, -1 point something and 4 point something are not equal, so unequal is the way that we would describe them there. So again, we just described the nature of the roots based on the fact that we had a number in our discriminant that was greater than 0 and non-perfect. So let me just revisit the top here. If we have a number that's greater than 0 and perfect, then the roots are real, rational, and unequal. If we have a number that's greater than 0, but non-perfect, then the roots are real, irrational, and unequal. So the only difference here is this middle word, irrational versus rational. And that's because the difference here is because we have either perfect or non-perfect. Perfect meaning rational, nice, pleasant. Non-perfect meaning irrational, not so nice. We've got 2 more cases to take a look at, and then we'll do some practice, some examples where we can actually apply what we're learning. So case 3, we've got this quadratic formula, or quadratic equation, x squared plus 2x plus 1 equals 0. So put your 1 in front, label a, b, c, and calculate your discriminant, b squared minus 4ac. Now do you see why I like to calculate this first? I never told you that, but this is part of the reason why I like to calculate b squared minus 4ac off to the side, because not only do we use it in quadratic formula, but we could always describe the nature of the roots, and I'm sure that you guys want to go home tonight and talk to your parents about the nature of the roots, because you're that cool. So we have 2 squared minus 4 times 1 times 1. 2 squared is 4, take away 4 times 1 times 1. Well, if I type that all into my calculator, then I get 0. So if I look at my roots here, where I cross my x-axis, I only see one of them, and that's at -1. Now, I know this is, you're probably thinking, oh, well, no, Miss Griffin, that's at -2, but notice how the counting is going here on this graph. Every 4 squares is 2. So that means every 2 squares is 1. So again, this is at -1. Now, the number of roots, there's only 1. And then we're going to describe it. Because it's crossing your x-axis, it is real. Because it's a -1 that can be written as a fraction, just simply over 1, then that means it's rational. And then the question is, are the roots equal or unequal? Because there's only one of them, if we were to actually factor this quadratic, you would have x plus 1, x plus 1. You would t-chart, you would get x equals -1, x equals -1. Now, technically there's 2 roots, but they're equal, which is how we're going to describe it at the end. Real, rational, equal. So we just discovered that if our discriminant is equal to 0, not greater than 0 anymore, but equal to 0, then the roots are real, rational, and equal. Alright, moving on to our last case here, case 4. So again, b squared minus 4ac, that's always your first step here. 2 squared minus 4 times something times something. I don't know if you guys can hear that noise in the background, but that's my cat playing in my hamper. Little Betsy's playing inside my hamper. So I've got 2 squared minus 4 times 2 times 3. Oh, I just made a mistake. Not 2. I'm sorry. We're looking for a here, so a 1 there. Go ahead and calculate that. Type it in your calculator. Once we type it in, we end up with -8. And if we look at our graph, you'll notice that the graph of the quadratic is not touching the x-axis, which means that there are no real roots. And so we describe non-real roots as imaginary. And this is because our discriminant, -8, was less than 0. So if we have a value that's less than 0, then that always leads to imaginary roots. Because remember, this is technically under a radical, and under a radical, negatives now turn into i's. So we can, change forms if we really wanted to. But here we don't have to. We just have to recognize if the value is less than 0, then it gives us imaginary roots. So we're going to take a second to do a little bit of practice here. Aren't I so nice here in these 2 examples? I've already calculated b squared minus 4ac. And in this first case, it gave us 81. So now we have to decide in each row, what are we choosing? Now remember, if we choose imaginary, we choose nothing else. If we choose real, then we got to keep going. Because if you think back to that branch earlier, the real side kept going. Kept going, kept going, kept going. Okay, so we have to make sure that we're choosing appropriately. 81 is a positive value, which immediately eliminates the option of imaginary, forcing us to choose real. Now 81 is greater than 0, that's where we got the real part from. And if I asked you for the square root of 81, you would tell me it is, now I'm imagining all of you saying 9, right? This is a perfect square because you can take the square root of it and it's nice. So being perfect, that means that it's rational. Yes, I just skipped a line. I went all the way down to the bottom and circled rational. Now, if it's real and rational, but greater than 0, then the roots are unequal. That's our case 1 that we saw way back when. All right, let's take a second to look at part B. b squared minus 4ac, all calculated, is 63. This is greater than 0, but if I ask you for the square root of 63, are you going to tell me a nice number or a bad one? Well, it looks like it's a bad one, meaning non-perfect. Alright, so take 30 seconds and try to circle the ones that you think are correct here. Is it real or imaginary? Is it equal or unequal? Are the roots rational or irrational? Again, 30 seconds, then I'm going to put my answers up here on the board. Alright, so I just circled real because it's greater than 0. I circled irrational because it's non-perfect. And I circled unequal because there's essentially 2 roots. We didn't actually calculate the roots, we've just calculated the discriminant, but it does describe the nature as unequal. Go ahead and flip the page. We're going to look at just another example real quick before I give you your classwork and your homework. Just kidding, it's not going to be me giving you your classwork and your homework. I'm making these videos for a reason because I'm not there. Alright, so part A says that we're given this quadratic and we have to describe the nature of the roots. So here, this is kind of like what we were doing with the cases. We have to start by calculating b squared minus 4ac. Now on your test, this formula is not given. Let me repeat that. This formula is not given, so you have to memorize it. I will always and forevermore give you the quadratic formula. X equals negative b plus or minus square root blah 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 blah. But I won't give you b squared minus 4ac by itself. So you have to recognize what it is and how to use it. So we've got our a, our b, our c. So we have 3 squared minus 4 times something times something. Fill it in. You don't need me. Plug it into your calculator. So when I calculate it, I get 25. Now 25, remember, is greater than 0, and it is perfect. So from here, we're going to decide, is it real or imaginary? Write down your answer on the top of your paper. Not the top, but to the side here. Real or imaginary? Then decide, are the roots rational or irrational? Then the last decision you have to make is whether or not the roots are equal or unequal. So here I chose real, rational, and unequal. The only time the roots are equal only when b squared minus 4ac equals 0. That's the only time the roots are equal, when it's equal to 0. All the other times it's not equal to 0. We're going to skip down to part C. I will put the answer to part B up on the board in just a few minutes, but let's move down to C. We have 9x squared equals 6x minus 1. Remember, the first step is to get it equal to 0, so think about taking away 6x and adding 1. Take away 6x and add 1. So now we have 9. Whoa, that does not look like a 9. 9x squared minus 6x plus 1 equals 0. Now we get to find a, b, c, and calculate b squared minus 4ac. Go ahead and do this. I'm going to let the video run while you're working. I'm going to show my work up here without talking, so that way you can check it as you go if you need to. However, you should be trying this on your own at this point in time. So because I found that my answer is 0, equal to 0, then the roots must be real, rational, and equal. I'm going to put the answers up here for parts B, D, and E. If you want to try them on your own, you'll have the answers up here on the board. But the next thing that you're going to be working on is either your classwork or your homework assignment, depending on how much time is left. If there's 15 minutes remaining, then you may work on your homework. If there's more than 15 minutes remaining, then we're working on classwork, just like we do when I'm there. Remember, you will have a ticket out the door in just a few minutes regarding this stuff. Some of them, they'll give you the discriminant. They'll say discriminant is 15. Describe the nature of the roots. Other times, they're going to have you calculate it. They'll give you a quadratic equation, just like you see here on this particular page of your notes. You'll have to calculate and then describe. So be prepared for both options. And again, check your answers for part B, D, and E if you choose to do them right now. Okay, so my answers up here on the board for B, D, and E are the following. Let me just grab a highlighter here. I think I'm going to highlight. I don't even know. Let's see. B, I have negative 23, which means that my roots are imaginary. D, and again, I'll leave these on the board so that you can check them. D, I found, I just crossed off on accident, whoops. D, I found positive 12, so my roots are real, rational, and unequal. And E, I found negative 8, so my roots are imaginary. And again, now at this point, you're working on homework or classwork, and then your ticket out. I'll see you guys tomorrow on the next video. Don't forget WPR number 19 is due on Friday.